Before there was an Earth, before there was a sun, there was only darkness. A great cosmic emptiness pierced occasionally by the faint glow of distant stars. Space was vast, quiet, and cold, but in one particular corner of the Milky Way, something remarkable was about to happen. It began with a cloud. Not an earthly cloud of water droplets, but a giant, sprawling nebula, a vast, ghostly expanse of gas and dust stretching for light years. For millions of years, it floated in silence, made of the ashes of long-dead stars. This material, carbon, oxygen, silicon, iron, was the debris from supernova explosions that had scattered the raw ingredients of planets and life across the galaxy. Then came the disturbance. Perhaps it was the shock wave of a nearby supernova, or the gravitational pull from a passing star. Whatever the cause, the calm balance of the nebula broke. Gravity, patient, invisible, and relentless, began to gather the scattered particles together. The dust and gas swirled into a slow, spiraling collapse, like water down a drain, except the drain was an invisible point in the center. Over hundreds of thousands of years, the collapse accelerated. As the cloud contracted, it spun faster, flattening into a great rotating disk, a protoplanetary disk. At the center, matter piled up until it grew so dense and hot that nuclear fusion ignited. A star was born, the sun, its newborn light flooding the dark corners of the disk. But the story of Earth had only just begun. Within the swirling disk of the young solar system, tiny grains of dust clumped together, colliding and sticking thanks to electrostatic forces. At first, they were small, pebbles, rocks. But over millions of years, these clusters grew into larger bodies called planetesimals, each one dozens or hundreds of kilometers across. These building blocks of planets collided violently, sometimes merging, sometimes shattering into fragments. In one region of the disk, about 150 million kilometers from the sun, the temperature was perfect, cool enough for metals and rocks to remain solid, but too warm for lighter elements like hydrogen and helium to gather in large amounts. Here, planetesimals kept colliding and merging, forming a rocky world in progress. It was not a peaceful birth. The young Earth was a molten, fiery sphere, its surface churning with lava seas and bombarded by asteroids. Volcanoes belched toxic gases into a thick, poisonous atmosphere. There were no oceans, no plants, no blue skies, only chaos. The surface temperature was so high that any water arriving on comets or asteroids instantly boiled away into steam. Then came one of the most cataclysmic events in Earth's history. About 4.5 billion years ago, a Mars-sized body, often called Theia, smashed into the young Earth at tremendous speed. The collision was so violent that it tore chunks of molten rock into space, forming a glowing ring of debris around the planet. Over time, this material coalesced to form the Moon. The impact also tilted Earth's axis, giving us the seasons we know today. With the Moon's stabilizing gravitational pull, Earth's rotation slowed, and its climate patterns became more regular. Gradually, the planet's crust cooled and hardened. Rain, fed by water-rich comets and volcanic steam, began to fall, filling low-lying areas to create the first oceans. The atmosphere changed too. Early on, it was mostly carbon dioxide, nitrogen, and water vapor, with traces of methane and ammonia. It was hostile to life as we know it, but it formed a protective blanket that kept the young planet from freezing in the faint light of the newborn sun. Deep within the oceans, something extraordinary was brewing. Hydrothermal vents spewed mineral-rich water into the seas, creating chemical reactions that scientists believe may have been the spark for life. Simple molecules formed and began to link into more complex structures. Proteins, RNA, eventually giving rise to the first microscopic cells. Over billions of years, life transformed Earth's atmosphere. Cyanobacteria learned to capture sunlight for energy, releasing oxygen as a byproduct. This oxygen slowly accumulated, turning the skies blue and paving the way for more complex organisms. Plants, animals, and eventually humans would owe their existence to those tiny pioneers. But even before life, Earth had been shaped by countless other forces: continental drift, magnetic fields, asteroid impacts, ice ages, and volcanic eruptions. Its mountains rose and eroded, seas advanced and retreated, and climates shifted. Every change was part of a grand cosmic experiment that had started with a quiet cloud of dust. When you look at Earth today, from space, a shimmering blue and green sphere wrapped in white clouds, it's hard to imagine its violent, molten origins. The calm oceans and fertile continents disguised the chaos from which they came. Yet every rock, every drop of water, every breath of air is a remnant of that ancient cosmic process. And so the Earth's story is both humble and grand. It is humble because our planet is just one of billions in the galaxy, formed by natural processes that happen elsewhere all the time. Yet it is grand because here, against impossible odds, matter learned to breathe, to think, to wonder about its own origins. We are, in the words of Carl Sagan, star stuff, atoms forged in the hearts of ancient stars, recycled through explosions, gathered by gravity, shaped by collisions, and awakened into consciousness on this small world we call home. From dust to life, from chaos to beauty, Earth's journey is a reminder that creation is rarely instantaneous. It is the patient work of billions of years, the slow sculpting of time, chance, and natural laws. And as our planet continues its path around the sun, the story is not over. We are living in its latest chapter. In the end, Earth came into existence not by magic, but by the quiet, unstoppable power of the universe at work, turning dust into worlds and worlds into havens for life.